I am Professor Somayajulu, working in Computer Science and Engineering Department at National Institute of Technology, Warangal. The title of this module, Online Analytical Processing. In this module, we have several lectures. This is the first lecture pertaining to concept of OLAP. In this lecture, we discuss the importance of OLAP, the comparison of OLAP system with the traditional OLTP system, the concept of multidimensional modeling. We also discuss what is the inherent structure widely used in building the multidimensional model. And finally, we conclude this lecture by discussing various kinds of operators that are useful for OLAP. OLAP is one class of application for integrated information systems called data warehouse. Online analytical processing technology is used for querying the data warehouse. OLAP is quite useful to answer more demand-oriented questions which cannot be answered using the traditional relational set. OLAP, of course, makes data synthesis, data analysis, and data consolidation quicker, easier, and smarter. This OLAP is one technology which is very widely used by the industries. Making rapid analysis of large quantities of data, OLAP is quite useful. OLAP is used for efficient information retrieval. The tools available today with respect to this technology will help the organizations in making better business decisions. We can analyze and structure the data the way the managers want to view the data using these OLAP tools. The key to OLAP is that users can express their data in the same way that they think about their data. Today, most of the commercial products like Oracle, IBM's DB2, SQL Server, Sybase, etc. are dominant players in the OLTP arena. With the relational database and OLTP engine, organizations gain the ability to capture data at the source, something that is not existed earlier. As the information available to the user community grow, the complexity of the user's requests for information is also grown rapidly. Eventually, the user is asking more demand-oriented questions which cannot be answered using the traditional relational tool set. Therefore, there is a need to answer more complex questions, fuel the momentum for additional change of the commercial systems. OLAP was evolved to answer such complex questions. As pointed out by Card, relational database management systems have been for users and they were never intended to provide more powerful functions for analysis. So now this technology OLAP makes the analysis easier, smarter and quicker. A process controlled by a computer, that is why it is called online. So what is controlled? By the technology process the analytical data. Analytical data means the data involved analysis is called analytical data. So that is the reason why it is called online analytical processing. Ultimately, this technology uses the business data, and if we process the business data which involve the analytical oriented values, then by using this technology we can find out the analysis quickly, easily and smartly. According to the OLAP Council, OLAP is formally defined as a high-capacity, multi-user data manipulation engine specifically designed to support and operate on multidimensional data structures. That means the data structure used is designed using a special structure called data cube. Such data structures are called multidimensional data structures. That is to say, OLAP can be defined as a technology which allows the users to view the aggregate data across measurements along with a set of related parameters called dimensions. For example, if you take the market analysis, product, organization, customer, etc. are the dimensions. Maturity amount, interest rate, etc. related to the measurements. OLAP consists of several distinct features. The most important feature is visualization, which is basically used to show the results in a better form for the end user. Then interactivity, customization, and security. Interactivity means how easy the end user interacts with the tool is known as interactivity. How easy the end user makes changes on the data representation provided by the tool is called customization. Then how easy the tool provides multidimensional graphical representations visually is known as visualization. And also how to protect the data that leads to security. Therefore, the key features of OLAP are interactivity, customization, visualization, and security. How nature-wise OLAP is organized. The data used by the OLAP technology is a highly summarized, archived, derived, or historical oriented data. The organization of the data is made by considering subject orientedness, and whatever the data is organized, that data is stable. It means that complex queries can be answered efficiently by using this technology, which is termed as optimized for complex queries. Frequency wise, very few number of users are going to access, and also they are not going to access the way the day-to-day application programs are accessed in our OLTP systems. The type of access is always read-only access or aggregated oriented access, and from the usage point of view, the queries are quite ad hoc in nature or unstructured. Since the huge amount of data and complex computations are involved, the response time system may take to provide the answers for the end users maybe ranges from several seconds to minutes. So this way, nature-wise, OLAP is defined or organized by taking the contents, organization, stability, frequency of the data, type of access, usage, and response time. Today, Oracle is a dominant player in OLTP arena. Of course, not only Oracle, but there are many other commercial databases exist today in the market like DB2, SQL Server, etc. A widely adopted definition for OLAP used today in 5 keywords is fast analysis of shared multidimensional information. Here F means fast. Fast refers to the speed that an OLAP system is able to deliver most responses to the end user. Analysis refers to the ability of an OLAP system to manage any business logic and statistical analysis relevant for the application and user. In addition, the system must allow users to define new ad hoc calculations as part of the analysis and report without having to program them. So S stands for shared. Shared refers to the ability of an OLAP system being able to implement all security requirements necessary for confidentiality, concurrent update, locking at an appropriate level, and multiple write access is required. M stands for multidimensional. This refers to a concept that is the primary requirement to OLAP. An OLAP system must provide a multidimensional view of data. This includes supporting hierarchies and multiple hierarchies also. And finally, I stands for information, which refers to all of the data and derived data needed wherever the data resides and however much of the data is relevant for the application. OLAP queries are influenced by spreadsheets and SQL. That is to say, OLAP query integrates the functionality of the spreadsheets and the functionality of the SQL. The popular operators used in OLAP are simple extensions to the traditional group by class of select statement. A common operation used in OLAP system is an aggregate operation. This operation will help to calculate numerical measure with reference to one or more dimensions. The slide shows 3 different kinds of queries. The first query is find total sales, which is computing the total number of sales is an aggregate operation. The second query also belongs to the category of aggregate operation, but over a combination of city and state. That means in each city the total sales is calculated. Third kind of aggregation is finding the top 5 best products ranked by total sales. So unless we do the aggregation operation, I can't find the top best 5 products depending on the sales. So most of the OLAP queries are always based on this type of operations. You all know that there are different kinds of aggregate operations in SQL. So all these aggregate operations are very widely used in OLAP. Can't we do this kind of processing using traditional systems? So the basic advantages of using a separate tool are shown on the slide. One main advantage is it empowers the end users to perform their own analysis, and of course it reduces the backlog report requests by the information systems, and ease of use and ease of understanding is another advantage, in the sense that the way the managers wants to view the data, if you structure, then managers can execute the request without understanding the basic concepts of SQL. That is another advantage. No knowledge of SQL or tables are needed for the executives or the end users. And it views the data from all angles, and we can structure the data the way the end users think. And ultimately the last advantage of using a separation of a tool is it is very appropriate for rapid analysis of large data.
Sir, my question is how concept hierarchy is different from conceptual schema of a DBMS?
His question is how concept hierarchy is different from conceptual schema of DBMS. Of course, both are part of design process, in the sense that conceptual schema of DBMS uses ER modeling to design a database schema or conceptual schema, whereas conceptual hierarchy is identified and represented in dimensional modeling for designing data warehouses. Dimensional modeling is the main modeling technique used for designing data warehouses, or in other words, data warehouse schemas. Functionality wise, both are different, but both are conceptually applied in design stages only. As you all know, in SQL, you can always define a conceptual hierarchy within a dimension. If you want to create a dimension in SQL, you have to use a statement called create dimension statement, which is similar to create table statement syntax, but the dimension statement is associated with the hierarchy. But whereas create table statement will never be associated with the concept hierarchy. So in that sense, there are language level description features exist in the SQL to define our own concept hierarchy. Skeletally, in a skeleton structure, we model the concept hierarchy, and then physically by using the SQL, we can create a logical schema by defining the hierarchy the way you want. So that way, conceptual hierarchy is very widely used in OLAP system. It's different from OLTP system by highlighting the differences between these two kinds of systems. As I mentioned earlier, OLTP is a transaction-oriented processing system, whereas OLAP is an analytical processing system. The differences are shown on the slide with respect to various parameters. When we consider the first parameter users into account, the main distinguishing features considered in comparing these two systems are users and system orientation, data contents, database design, view, access patterns, size of the database, frequency of operations, and the performance metrics. Users and system orientation. When you consider users into account, the main user in OLTP is either a clerk or IT professional. whereas knowledge worker is the main user in OLAP system. From the system orientation point, customer orientation is used in OLTP, market orientation is used in OLAP system. In the sense that to run the applications, day-to-day applications, the customer orientation is taken into account in OLTP systems. To analyze the market, OLAP systems are taken into account. Managers, business executives and analysts are related to knowledge worker category here. Second category of comparison is function. From the function point of view, OLAP always uses additional support criteria into account from the perspective of informational and decision support requirements, whereas OLTP always concentrate on the normal day-to-day operations of the applications. Regarding the design of the database, OLTP is mainly centered on application-oriented nature, whereas OLAP is subject-oriented in nature. Here, the application-oriented nature means that traditional normalization techniques are used to design the database schema in order to run the applications day-to-day in an efficient manner. Whereas in OLAP systems, the main concept used is star schema, snowflake schema, or fact constellation schema by treating the subject-orientedness into account. From the data contents point of view, OLTP always maintains the current and up-to-date data and uses more detailed data for decision making. In the case of OLAP, large amounts of historical data is considered, and such systems provides a mechanism for summarization and aggregation. It also stores and manages information at different levels of granularity. These features will help to use effectively in making well-informed decisions. From the parameter viewpoint of view, OLTP uses always current and latest data within an organization or a department only. In the case of OLAP system, it always refers to historical data integrated from different organizations, which results in huge amounts of data. Such a huge amount of data is maintained over a period of time. Access patterns point of view, very short and atomic transactions are part of OLTP system and needs concurrency control and recovery procedures, whereas OLAP systems uses read-only operations and complex querying. Therefore, it doesn't require any concurrency control and recovery procedures. The number of records accessed are tens of thousands of records in the case of OLTP system, whereas it is millions of thousands of records in the case of OLAP systems. From the database size point of view, OLTP system may take 100 megabytes to 1 gigabyte size into account, whereas OLAP need 100 gigabyte to 1 terabyte of size into. The main metric used in OLTP is the maximization of transaction throughput, whereas the main metric used in OLAP is query throughput and quick response time. From the user's point of view, the number of users in OLTP system are more compared to the number of users who use OLAP system. From the comparison point of view, we can say that thousands of users may be in the case of OLTP, whereas very few hundreds of users may use the OLAP system. So far, we discussed about the comparison of the two systems, namely OLAP and OLTP.
Sir, my question is, what is the difference between OLAP and OLTP system?
Okay, the difference between OLAP and OLTP systems. As you all know, OLTP is an acronym for Online Transaction Processing System, whereas OLAP is an acronym for Online Analytical Processing System. In OLTP is used for managing the day-to-day operations of an enterprise, whereas OLAP is used to manage the business across all the enterprises. I explained this earlier, but for the benefit of students, I am explaining once again the basic differences between OLTP and OLAP. In a simple way, OLAP is used for enabling decisions. That means for decision support system based applications, we use OLAP systems. Whereas the record keeping system or bookkeeping system is nothing but OLTP system. Day-to-day operations in a bank, day-to-day operations in a university, they are all bookkeeping systems. So I compare all these two concepts on different kinds of points. The first point is business need. From the perspective of business need, OLTP, the main business of OLTP is to do or to execute the transaction successfully. Booking of a ticket is a business, right? Cancellation of a ticket, postponement of a journey, they are all day-to-day operations. From the OLAP perspective, business need is analytical. That means, why should I introduce a first-class AC coach in a particular train? What is the reason behind the introduction of that train? Who has to do that decision? Some decision must be taken by the railway minister or high-level executive. So to make such decisions, he needs some analysis. So that is why OLAP is used for analytical purpose. By observing the past history of all the passengers travelled across that route on each day, how many times the coaches went wrong with empty number of passengers, all these things are part of analysis. Then coming to the next comparison is query. From the query point of view, OLTP is basically very simple in nature. Simple in the sense, using the application need, I can write a simple select statement here. Query is not quite complex here. Very simple, easy to understand, and easy to run the day-to-day applications. Whereas from the OLAP point of view, the queries are quite complex because there are varied levels of combinations of aggregations exist at the back end of your data warehouse. So that's why to enable a decision by the decision maker, the system should provide ease of retrieving these complex results. That is the reason why we use the concept of OLAP and multidimensional modeling here. Then coming to the next concept, time frame. From the time frame point of view, OLTP is always point in time. Point in time means what? If you see any relational database online systems, 24/7, if flight reservation system, suppose if you want to go by air, you always open a website and then you are booking a ticket. So that is, on that day, you are booking means, on that day how many seats are available in a particular flight. That is point in time. Always the databases always uses the latest consistent data, up-to-date data. There are no versioning concept here. Every database always changes and purchases the old value and then keeps the latest computed value. That is point in time. We are referring to the current data. If you go to the bank, you always ask what is my balance today. You cannot go and ask what was my balance on January 1st, 2008. That is not point in time. Whereas the latest balance is a point in time. Then from the OLAP point of view, history, past history. What are all the different details? Who are all the different kinds of passengers traveled on a particular day or in a particular coach? Depending on that, we are making a decision. So that's the historical data. Then the next concept is business question. In the transactional systems, business question is always known. Reservation of a ticket. Query, how many beds are available? Which class, on which day or which class the reservation is available. That means they are very clear. Every application clearly knows the questions. But from the OLAP point of view or from the decision support system point of view, the questions are always unknown or quite head up. In the sense that the manager's mind always changes spontaneously depending on the events that are going to occur on a particular day. So for example, when he goes to the office, his boss may call and then he may shout on him and then he may ask to give the details as early as possible. In that situation, he may ask some question which may not be known very clearly to observe the functionality of the system. So in that sense, tell me something which I don't know is an unknown question. Such kind of questions also must be answered by using this system. Then coming to the next concept, business environment. The business environment in OLTP is always static. Whereas in OLAP, the business is always dynamic because there will be many competitors, many enterprises are working simultaneously to improve their business, or in order to improve their business, they have to take good decisions, action-oriented decisions. You may take a decision, but if you don't implement, then you may lose your business. So that's why highly dynamic environment is used in a OLAP system. But whereas OLTP is always static system. Okay, this way you can understand or compare the OLTP with OLAP system. But in my first topic of the presentation, I explained in detail about the OLAP versus OLTP on various issues, like concurrency control mechanism is required or not, or what kind of modeling is to be used for OLAP and what kind of modeling is to be used for OLTP. Please refer the notes or slides of my presentation for further details. Now we talk about what is the specialty of OLAP system and how efficiently the analysis will be carried out using OLAP system. This is possible based on the multidimensional. Before going into the details of multidimensional model, first we talk about why do we need multidimensional analysis. Whenever we pose queries such as how many units of item did we sell in the store located in Hyderabad, say, are no longer give satisfaction for decision makers. From the decision maker point of view, how much revenue did the new item, say X, generate during the last 6 months, broken down by individual months in the state of Andhra Pradesh, by an individual stores, broken down by promotions, compared to estimates and compared to the previous version of the product is much more interesting rather than running the day-to-day queries for the decision maker. Decision maker can further extend the above such requests for further comparisons to similar products, comparisons among different regions, and views the results by rotating the presentation between the rows and columns. So such queries involve complex query processing. That is to say, to answer such queries, the system should do a lot of complex query processing. For effective analysis, decision makers should have easy methods of calculating complex analysis along several business dimensions. Such an environment can be established using multidimensional view of data. Such kind of view provides the basic foundation for analytical processing through easy and flexible access to information. Decision makers must have ability to analyze data along any number of dimensions at any level of aggregation with the capability of viewing the results in varied number of ways. Also, they must have ability to navigate the results from one level of summarization to next lower level of summarization and vice versa. These type of facilities are not so easy in the traditional query processing. Therefore, we need a solid system. So to do such processing, we need to use the concept of multidimensional modeling. Of course, time is also a very important dimension in any analytical system. Every analytical query is executed with respect to time, and it is unique in nature because of its sequential nature. An analytical system must recognize the sequential nature of time. So this is another factor why traditional systems are not appropriate for answering complex questions which are very demand oriented from the decision making point of view. Hence, multidimensional analysis very much essential feature in OLAP technology. So what is multidimensional data model? Multidimensional analysis is a popular analysis oriented approach to extend the additional features for query and reporting. Instead of submitting multiple queries, data is structured to trigger fast and easy access to answer the questions posed by different kinds of users. This kind of analysis is generally performed on large corporate data warehouses or data marts using the so-called multidimensional data model, consisting of 3 dimensions, namely product, location, and time, and sales, which is a measure across these 3 dimensions. Generally, the multidimensional data model focus mainly on collection of numerical measures called facts. For example, sales is a measure, total sales is a measure which is a fact. and depends on a number of associated dimensions. So the associated dimensions here are the sales of a particular product over locations over a period of time. So locations, product, time are dimensions. This model views data in the form of a structure called data cube. To analyze the relationships between the dimensions, we record numerical quantities. To analyze the relationship between the three dimensions, we recorded the numerical quantity, say total sales amount, the number of units sold, the total budget, etc. are termed as facts in the sales fact table. In addition to facts, the fact table also consists of keys to each of the related dimension tables. Such models naturally adopts structures, namely star schema, snowflake schema, and fact constellation schema. The dimensions are the perspectives or entities with respect to which an enterprise is willing to maintain records. For example, here the location is a dimension. Each dimension may have a table associated with it called dimension table, which describes the dimension. Data cube is defined in terms of n dimensions, namely d1, d2, dn. When n is equal to 2, it provides a two-dimensional view of data called two-dimensional data cube, which is nothing but a table in our relational terminology. When n is equal to 3, that means when the number of dimensions are equal to 3, it is termed as a three-dimensional data cube. A three-dimensional data cube is viewed as a collection of a series of 2D data cubes. That is a series of two-dimensional data cubes. For example, in this slide, we have shown a three-dimensional data cube, which is a collection of different tables. One table for each location. For location is equal to 1, the sales at location 1 over a period of time are shown here in this slide. Similarly, the sales for the same period of time at location number 2 can be considered as a second table. So like that, if we have several locations, one table for each location is used. That is to say, an n-dimensional data cube is viewed as a series of n-1 dimensional data cubes. Hence, a metaphor for multidimensional data storage is a data cube. However, the physical representation for this is quite different from its logical representation. In data warehousing literature, a data cube is nothing but a collection of cuboids. An n-dimensional data cube will have 2 power n cuboids. Each cuboid is generated by taking a particular subset of the given dimension. The collection of all cuboids is termed as a lattice. The slide shows the lattice of cuboids involving 3 dimensions, namely product, date, and country. So in this slide, you can see different kinds of cuboids. Total sales are computed. It is called a 0-dimensional cuboid, which is also termed as apex cuboid. Instead of that, if you are interested in finding the aggregations only for each dimension, say the sales, total sales for each product, the total sales for each day, total sales for each country, they are called one-dimensional cuboids. Instead of that, if you consider the total sales on each day for each product is an example for two-dimensional cuboid. Similarly, total sales for each product over each country, or total sales on each day for each country. So these are the examples of two-dimensional cuboids. If you take total sales on each day for each country over each product, which is a base cuboid called three-dimensional cuboid. So if you observe this structure imitates the behavior of the concept of lattice. You all know that a lattice is a very popular structure used in discrete mathematics. A partial order sort with the greatest lower bound and least upper bound is called a lattice. So here if you observe, the greatest lower bound is the total sales on each product for each date over each country. You may have different kinds of sales here, different kinds of values. So each value is derived from the combination of these 3. And there is another measure called least upper bound, which is grand sales. So between the grand sales and the individual sales of each product over each day and each country, there are different varied levels of summarizations. You take any summarization, the whatever the result we get with respect to that summarization, that result is always less than or equal to the least upper bound and more than the greatest lower bound. That is the reason why it imitates the concept of lattice. So in a nutshell, you can say that a data cube is nothing but a lattice. The next slide shows one more extension of this three-dimensional data cube by incorporating one more dimension called supplier. So if I add another dimension supplier, we will have 2 to the power of 4, that is 16 cuboids. Zero-dimensional cuboid involving all the cells, and base cuboid involving the 4 dimensions. And between these two will have varied levels of summarization. So in this slide, time, item, location and supplier are termed as dimensions. Lowest level summarization is placed at 4-dimensional cuboid called base cuboid, and highest level summarization is placed at 0-dimensional cuboid called apex cuboid. Total sales is the highest level of summarization over all 4 dimensions, whereas sales for an item in a location supplied by a supplier in a year is the lowest level of summarization. Between these two extremes, there can be different levels of summarizations. In addition to, as I mentioned earlier, whenever you compute the data cube, for each combination of the dimensions, we are doing the aggregations. But we can also reduce the number of aggregations by using the concept of hierarchy. Each dimension can also be hierarchically organized. For example, if you take the product names, so these products can be categorized. They may be hierarchically organized into the different categories related to a particular industry. So therefore here there is an hierarchy exists between product, category and industry. If you take another hierarchy, office, city, country, region. A city is a collection of offices, and collection of cities may be there in a country, and collection of countries can be considered as a region. And if you consider hierarchy over a time, we can have one or more hierarchies possible. For example, collection of days is a month, collection of months is a quarter, collection of quarters is a year, is one kind of hierarchy. Collection of days is a week, and collection of weeks is a year, is another kind of hierarchy. So as far as the time is concerned, we can have multiple navigations. So by using the hierarchical summarization, hierarchical nature of dimensions, we can reduce the summarization paths for a data cube. If there is no hierarchy among the dimensions, the number of summarizations will be enormously large. So in order to reduce those summarizations, we use the concept of hierarchy.
How OLAP operations differ on n-dimensional view of a data cube?
Question is, how OLAP operations differ on n-dimensional view of data cube? All OLAP operators that are discussed in this lecture will always work on any dimensional structure. Whether it is a one-dimensional structure or two-dimensional data cube or three-dimensional data cube or more than 3 dimensions, that is n-dimensional data cube. As I mentioned earlier, hypercube must be viewed as a general visual metaphor for representing aggregations of higher dimensional data. So therefore, whatever the way the operators work on either 2 dimensions or 3 dimensions, in the same way the operators will work on n dimensions. Suppose if I want to do slicing on an n-dimensional data cube or a particular dimension attribute, then the result will be an n-dimensional result will be n-1 dimensional data cube. Suppose if it is a 3-dimensional data cube, if I use slicing, then you get a 2-dimensional matrix. If it is a 2-dimensional data cube, and if I use slicing, by fixing one attribute value, you get either a row or column. So there is no much difference as far as the processing of the operations are concerned with respect to OLAP system, but from the results point of view, the number of aggregations or the number of dimensional values and aggregations will be enormously large in an n-dimensional cube. But functional devices all work with the same principle. There are convenient set of operators available in OLAP. They are namely slicing, dicing, drill down, roll out and pivot. These typical operators are available as part of most of the OLAP tools. When the data are organized in the multidimensional model, where each dimension consisting of multiple levels of abstractions depending on the associated concept hierarchy definition. This type of structure provides users with the flexibility in viewing data from different perspectives. Basic OLAP operators assist the user for interactive data analysis. We now discuss each operator briefly. The purpose of slicing is used to focus attention on subset of dimensions. Basically, it is used to replace a dimension with a single member value or with a summary of its measured value. Visual representation in a data cube allows intuitive manipulation. Usually this kind of manipulation doesn't exist in any query language. Another kind of operator is called dicing, which imitates the selection operation in relational algebra, whereas slicing imitates the concept of projection operator of relational algebra. That means pi of relational algebra. The purpose of dice operator is to focus attention on a subset of number of values. That means we can replace a dimension with a subset of members, which is nothing but a selection operator. Third operator is called the drill down. The purpose of using drill down operator is to obtain more detail about a dimension. That means you can navigate from more general level to a more specific level. Whereas roll-up is an operator used to summarize details about a dimension. That means you can navigate from more specific level to a more general level, which is a reverse process of drill down operation. And the last operator is called pivot. The purpose of using pivot is to present data in different order. That means using this operator we can rearrange the dimensions in a data cube. Normally drill down, roll up and pivot operators are used for hierarchical based dimensions. Drill down adds detailed stays dimensions, whereas roll up removes the details from a dimension. Pivot is basically used to rearrange the dimensions. As I mentioned, OLAP provides the basic operators for interactivity and better visualization. The key feature of OLAP is it is fast, flexible access for summarizing the data. So this I will explain with an example what is meant by fast, flexible access to summarize the data. The slide shows different kinds of views. When each user is interested to view the data in different way, then we will have different kinds of views of the same data. For example, a product manager is interested to view the data for his product across all markets. So one view is how to view the product details across all markets. At the same time, there is another manager called regional manager who is interested in sales for all products across the territories for which he is responsible, which we name this as a second view. At the same time, a financial manager or analyst is interested to perform a period-to-period comparison across all products and markets. This is the third view. In fact, any manager or analyst is likely to want to subset the sales data in some unanticipated way in order to answer a question that they have to answer on a particular day, say. This is the fourth view. So if you take all these four views into account, all these four views in fact access the same data in a different way. So multidimensional view is not only sufficient to answer these four questions simultaneously. So it is the combination of these flexible views with the analysis that provides the real benefit of OLAP technology. The calculations which support the analytical process are inseparable from the query process and viewing process. If you observe the slide, all these four views are combined into a single structure called a data cube, which is known as sales. Since all these four views are interested in measuring their sales values over the combinations of time, market, products. One view may be interested in viewing the combination of a product market combination. Another view may be interested in viewing the combination of all these three. Another view may be interested in viewing only the product's details by taking over all periods of time and markets into account. So, in order to provide these kinds of answers very easily, these OLAP operators like slicing, dicing, drill down and roll up and pivoting will help the analyst to view the data the way they want to view it. So that is the reason why data cube design play an important role in OLAP processing. In this lecture, we discussed the importance of OLAP and its need, comparison of OLAP system with the OLTP system, the concept of multidimensional modeling, how the data cube is to be built using the concept of lattice, and the various operators that are very widely used in OLAP system. In the next lecture, we discuss more details about the OLAP operators and how to efficiently build the data cube